Hey everybody, welcome back to the Digilent studio. My name is Nate, and today I'll be talking to you about some digital design concepts and an implemented design on Arty, one of our FPGA boards. Digital logic designs can become quite complex, even for things that are conceptually simple. For example, implementing a design for something that performs the basic operations of a calculator can end up looking something like this. That's why it's important that we follow design methods that allow us to explicitly determine how a component or system of components is supposed to behave. Things like truth tables, logic gate diagrams, and block diagrams allow us to do this. The circuit we're looking at today is an adder circuit, which will take two 4-bit input values and output a binary result. This demo is from Digilent's educational materials available on our Learn site. Those materials were written for our Nexus and Basis boards. So due to some I/O differences between those boards and the board we're using today, I'll talk about a couple ways to adapt those projects to be run on Arty. But first, let's talk about the design. So the logic behind the circuit is exactly the same as what you're familiar with from learning addition in elementary school. Here we have two input numbers, and each respective place value is added together to get the place value for the result. If you go over your maximum value, 9 for normal base 10 numbers or 1 in binary, then you can have a carry over number or carry out bit. That carry out bit is then included in the addition in the next place. This process is repeated until you run out of places to add. With our inputs and outputs now accounted for, we can create a truth table to see how this operation plays out logically. Observe that we have two outputs that are dependent on our inputs in two different ways, which means that we need two different methods of determining their value. We can use logic gate diagrams to illustrate how our input data interacts together to produce our desired output. These diagrams are representative of the operations that will be done on individual bits in our binary numbers, which is referred to as a bit slice method. From here, we can put our pieces together into a block diagram. From our block diagram, we can see how our two 4-bit inputs are added together bitwise to produce our output. So now to our hardware. As I mentioned before, if you're using the demo on our Learn site, you'll need to make some changes in order for it to be run on Arty. One method using just the I/O on the board will involve you needing to assign the 4 switches as one input and the 4 buttons as the second input. With the input method taken care of, you can assign your board LEDs to the output. You now have the basic means to implement this adder, though one of your inputs will be non-static. Alternatively, you can use PMODs. Here we have assigned the pins associated with our two PMOD switches as the inputs and a PMOD 8 LED, which will allow us to display the output number of the adder, including the 5th overflow bit. Links to this project and similar digital logic materials are available in the description below. Thank you for watching, and please subscribe to stay up to date with Digilent's products and services.